Hi everyone. Today we're going to keep talking about solving equations by factoring, and what we're going to do is we're going to mix the types of factoring together. So the good news is this is one of those days we're not really learning anything new. We're just taking a couple different things that we've done before and putting it together. So when it comes to solving by factoring, we know how to do it by factoring quadratics. That's what we did 2 lessons ago, where you take a quadratic and you factor it into like x plus 5 times x minus 3 or something like that. Now we know how to solve by factoring out common terms. That's what we did in the last lesson. That's like the reverse distributive property. Today, we're going to look at some examples where you have to do both types of factoring in order to be able to solve. Now, you always want to try common terms first. Every time you're factoring, you just want to take a second, look at the question, and just ask yourself, are there any common terms I can factor out? If there are, do that first. Sometimes you have to. Sometimes the question won't even work unless you do it. Other times the question might work, but it's going to be way harder. But no matter what, if there are common terms to be factored out, that's always the best first thing to do. So let's start with this example here. We want to solve for x. We have 4x squared plus 16x plus 12 equals 0. So as I'm going through my mental checklist here, the first thing I do is I say it's equal to 0. That's always the first thing I look for. I go, good, it's equal to 0. That's what we want. We need that to be able to solve by factoring. The second thing on my little mental checklist is I say, is there any common term I can factor out? And I say, yeah, I see a 4, a 16, and a 12. Those can all be divided by 4. So let's say if I start working on my GCF, my greatest common factor out here, I can definitely divide out a 4. Let's see if I can divide out an x. And I look at it and I say, well, I can't because of that 12. The 12 doesn't even have an x in it. If there's no x in it, you can't factor 1 out. So my GCF is 4. Let's do that. Let's divide everything by 4. And then remember, what you're really doing is you're doing distributive property backwards because you're dividing instead of multiplying. You're taking those 4s and you're bringing them out front. So what I have now, we'll bring that 4 out front. We'll see what's left over in just a second. It's still equal to 0. So let's do each part. The first part, the 4's cancel, and you just get x squared, plus the second part, 16 divided by 4 is 4, and we'll leave the x, plus the third part, 12 divided by 4 is 3. So I factored out the 4. I have x squared plus 4x plus 3. That looks more like our familiar quadratic. So for step 2, let's see if we can factor that. Let's leave the 4 and try to factor this into 2 different what we call linear factors, which is like x plus some number or x minus some number. So for this part of the problem, I am looking for 2 numbers that multiply to positive 3 and add to positive 4. Now 3 is a pretty easy one to work with. There's only 2 possibilities. 3 could be 1 times 3, or it could be negative 1 times negative 3. And the very first ones I thought of are our answer, 1 and 3. So positive 1 and positive 3 are my numbers because 1 times 3 is 3, and 1 plus 3 is 4. So I'm going to put a plus 1 in one of my factors and a plus 3 in my other. Now, we're ready to solve. We factored. We actually have 3 parts now because of that 4. So there's 3 things here. We have a 4. We have an x plus 1. We have an x plus 3. We're multiplying it all together, and the answer is 0. That means one of those 3 things has to have been the 0. So let's try it out. Let's take a look at some of these. Let's try this one. Maybe the 4 is the 0. Now it's not because it's a 4, but we'll come back to that in just a sec. Maybe the x plus 1 is the 0. Or maybe the x plus 3 is the 0. Based on the 0 product property, we know that one of those things has to be 0 because we're multiplying them all together and the answer is 0. So start off with the 4. 4 is not 0. 4 is 4. So we're just going to throw this one out. I mean, that's not the 0. We already know what it is. It's a 4. So one of the other two things is the 0. Let's solve each one. On the first one, I have a plus 1 I want to cancel, so I'm going to subtract 1 from each side. Cancel that out. X drops down. 0 minus 1 is negative 1. So there's your first answer, x equals negative 1. Let's try the second one. I have an x plus 3. I want to cancel the plus 3. I'll use a minus 3. Plus 3 and minus 3 are gone. X drops down. 0 minus 3 is negative 3. So those are your two answers there. X equals negative 1 and x equals negative 3. And we did it by doing both types of factoring. We factored out the 4 first, that was common terms. And then we did the quadratic factoring second by finding the numbers and figuring out our two factors are x plus 1 and x plus 3. All right, let's try one more. We have solve for x. We have 3x cubed minus 12x squared equals 15x. Now, if I walk through my checklist, I get an immediate red flag here. That's not 0. That means before anything else, step 1, we need to make it equal to 0. That's a 15x, so I want to start by subtracting 15x from both sides. Cancel that out. Now I notice there's no x on the other side. And remember, if you see an x term on the other side, line it up so you can add or subtract to that. What we want to do is kind of squeeze it in there and make a spot for it at the end. So I'm going to put the minus 15x right there, although I'm not subtracting it from the minus 12x squared. Those are not like terms. Now what happens? 15x minus 15x is 0, so we got the 0 we wanted. Now let's recopy and just leave a space to put that minus 15x at the end. So we have 3x cubed minus 12x squared minus 15x equals 0. Okay, step 1 is done. It's now equal to 0. We needed that. Step 2, let's look for a common term to factor out. Let's look for a GCF. Now, I look at my numbers. I have a 3, a 12, and a 15. I can divide all of those by 3. So that's going to be part of my GCF. And this time, I do have an x everywhere. I have an x cubed, an x squared, and an x. Now, because that variable is in all of the terms, I can factor out the lowest powered one, which is just x. So this time, let's put this in parentheses. I am dividing everything by 3x. Reverse distributive property, that brings it out front. So what I get is, we'll bring that 3x out. We'll leave it equal to 0. And let's see what's left over. So for my first term, the 3's cancel. Those are gone. I have x cubed divided by x to the first. That would be x squared. Remember, you subtract the exponents. 3 minus 1 is 2, so you get x squared. Then I have my minus. Number part, 12 divided by 3 is 4. X part, x squared divided by x is x to the first power, or just x. Last one, minus, again. Number part, 15 divided by 3 is 5. And the x's cancel, so there's no x in your last one. So we factored out 3x, we factored out our common term. Now what's left over in the parentheses, again, it looks familiar. It looks like maybe I can factor that. It's quadratic. So let's try that. Let's leave the 3x and try to factor this into two different x plus or minus somethings. This time, I need two numbers that multiply to give me negative 5 and add to give me negative 4. So if I make my list for negative 5, there's only two possibilities again. It could be positive 1 times negative 5 or negative 1 times positive 5. Now the ones that add up to negative 4 are the top ones. Positive 1 plus negative 5 equals negative 4. So I'm going to put a plus 1 on one of my factors and a minus 5 on the other. So I have completely factored. I factored out common terms. I factored the quadratic that was left over, and I have the same situation as last time. I have 3 parts, and each one of them might be a 0. 3 things multiplied together. The answer is 0. Each one of them might be the 0. So let's do them one at a time, and I'm out of space, so I'm going to start over the right over here again. But we'll do this one first. Either the 3x equals 0, or this one. Did that one, we'll do this one. Or the x plus 1 equals 0, or this one, the x minus 5 equals 0. Now this time, remember the last time it just said 4 equals 0, and we said that's a 4. 4 is not a 0. This one has an x in it, so that one's going to give you a third answer here. In fact, if I have 3x equals 0, what I want to do is cancel the 3. So I divide both sides by 3. 0 divided by 3 is still 0. So my first answer, my first possible answer is x equals 0. For the second one, I have an x plus 1, so I'm going to subtract 1 from both sides, cancel that out. 0 minus 1 is negative 1. And for my last one, I have an x minus 5, so I'm going to use a plus 5 to cancel that. And x ends up equaling 0 plus 5, which would be 5. So you have 3 possible answers, 0, negative 1, and 5. And before we end the lesson today, I want to make sure you really understand, remember when we factored out a common term? On the first question, the common term was just a number. That did not give us an extra answer. If I factor out a 4 is just a 4. It can't be 0. But anytime the common term has an x in it, or even up here, anytime your GCF has an x in it, that can give you another answer, and that's a third part that you need to try. That's a third thing you need to set equal to 0 and solve. So one little trick there. If the GCF is a number, like our first example, 4, it doesn't give you an extra answer at the end. But if your GCF has an x in it, like this one, 3x, it does.